Okay, so this is the key to the first part of your semester exam review. And so this first one says, name 3 points that are collinear. And remember, collinear means that there's points that lie on the same line. If it said coplanar, those would be points and lines that lie in the same plane. So collinear means on the same line. It means I can draw a line through them, one line through all 3 points at the same time. You don't necessarily have to see the line in here, but we do. So the only 3 collinear points we have here would be D, K, and J. To name a point, it's just a capital letter. And that's the answer to number 1. Number 2, name the intersection of plane HDG with plane X. So if 2 planes are going to intersect, they intersect at exactly 1 line. So I know my answer has to be a line. Plane HDG is this plane right here. Plane X is the bottom, or the parallelogram looking thing that you see. So their intersection would be this line right here. So my answer is line HG. At what point do lines LM and EF intersect? Well, if 2 lines intersect, then they intersect at exactly 1 point. And LM is this line right here. EF is this line right here. So, do you think they intersect at that point right there? The answer to that is no, they do not intersect. So they don't intersect, but they're not parallel. They are skew lines. Okay. Remember, skew lines are the lines that are not parallel and do not intersect. They look 2-dimensionally like they intersect, but 3-dimensionally, if you think about that, those 2 lines will not touch each other. Okay, so then we're going to use the diagram to complete the following. It says that M is the midpoint, so that means these 2 pieces are congruent. That was already labeled for me. So line segment CM has to be congruent to line segment MD. The length of CM equals the length of MD. The length of CM would be half of the whole thing, which is the length of CD. And then the length of CD, there's actually 3 different answers you could have here. The length of CD is CM plus MD, or 2 times the length of CM, or 2 times the length of MD. Then it says, give a counterexample. If angle 2 and angle 3 are supplementary, then angle 2 and angle 3 are a linear pair. Remember, if you want a counterexample, you want the first part to be true and the second part to be false. All right, so if I have this, 2 and 3, this is not a counterexample. That supports that. That makes them supplementary and a linear pair. So that's not a counterexample. If I want the first part to be true, I want them to be supplementary, but not a linear pair, it could look like this. So this is not my counterexample. This is my counterexample because they do not have to be adjacent. All right, so then we're looking for another counterexample. Oh, no, that goes, yeah, well, that was that question. So every 4-sided closed figure with all sides equal in length and with opposite sides parallel. It says statement above. That's why I'm confused. This actually goes with this. It's the statement below. So I want a counterexample. Every 4-sided closed figure with all sides equal in length and with opposite sides parallel is a square. Okay, so first things first. This is not the best question in the world because you don't have anything that's labeled congruent and anything that's labeled parallel, so you're supposed to assume things, which is bad, bad, bad. That won't happen on the test, but this is a former test question from a test that I did not write. So what we're looking for, so we're going to assume on this one only because it's a review, but it's a good time to remind you that you cannot assume. So every four-sided closed figure with all sides equal in length and with opposite sides parallel is a square. We are looking for a counterexample, so we want the first part to be true. Figure with all sides equal in length. Okay, so these two right here do not have all sides equal in length, so those cannot be my answer because the first part has to be true. These two do have all four sides equal in length. Okay. And with opposite sides parallel, all right, so opposite sides are parallel in both of those, is a square. All right, so first part, all sides equal in length with opposite sides parallel. Those two are true. The second part is that it's a square, so I need the second part to be false to be a counterexample. This one is intended to be a square, even though we shouldn't be assuming. This one is not, so this is not my answer. This is an example of something all four sides equal in length, opposite sides are parallel, and it is not a square. All right, this is a rhombus. You have to know that word. All right, number 9. Given the true statement, if you want to help preserve the environment, you conserve fuel, which statement is also true. So remember, don't look through these and try and decide what you know about the environment, who cares about the environment, who doesn't, what you do about fuel. None of that matters. The actual content of these sentences does not matter. What you are looking for is, if I want a statement that is also true, I look for logically equivalent statements. So remember, you have a conditional statement, if P, then Q. You have a converse, which is if Q, then P. You have an inverse, which is if not P, then not Q. And you have a contrapositive, which is if not Q, then not P. All right, so those are your 4 different kinds of statements. The logically equivalent statements are these two and these two. So if my original one is this is my if P, then Q, I am looking for if not Q, then not P. I'm looking for the contrapositive. So I'm looking for something that starts with, says if you want to help preserve the environment, then you conserve fuel. So I want it to be if not the conclusion. So if you're not conserving fuel. So let's look at these. This says if you conserve fuel, so that's not it. If you do not conserve fuel, so I'm going to save that one. If you want to help preserve the environment, nope. If you do not want to help preserve the environment, nope. So the only one that even starts with the if not Q part is this one. So let me just double check that it works. If you do not want to conserve fuel, then you do not want to help preserve the environment. So that is if not Q, then not P. This is the one that has the same truth value. Okay. All right, so then let's look at the next one. It says if quadrilateral ABCD is a square, then it is a rectangle. It says which of the following is the inverse of the statement above? Inverse. So remember, you have conditional and then converse, inverse, contrapositive. So if the original one is if P, then Q, what we're looking for is if not P, then not Q. So if quadrilateral ABCD is a square, then it is a rectangle. So I'm looking for it to start off with if it is not a square. So this first one says if it's not a square. Hang on to that. The quadrilateral is a rectangle. Nothing about a square. The quadrilateral is not a rectangle. Nothing about a square. My answer is A. Because this is if it's not a square, then it is not a rectangle. That is your inverse of the statement above. All right, which statement has a true converse? So I need to figure out what the converse is and then the truth value. The truth value of these is irrelevant because the truth value of the conditional and its converse are not always the same. So the converse of this one, if the number is prime, then it is odd. So if it is odd, then it is prime. That's the converse, basically. If the number is divisible by 10, then it is divisible by 5. So if it is divisible by 5, then it is divisible by 10. And if an angle is a right angle, then the angle measures 90 degrees. So if it measures 90 degrees, then it is a right angle. Okay, so there are my converses written very cryptically just so that we can get an idea of them. So the truth value that I'm looking for is of these, not of the statements that were given to me. So if a number is odd, then it is prime. So let's think about that one. That's the one that throws us off sometimes. So let's just hang on to that for a minute. If it's divisible by 5, then it is divisible by 10. Well, just take 5 even, or 25. That's divisible by 5, not divisible by 10, so that is not a true statement. If an angle is a right angle, then the angle measures 90 degrees. So if it's 90 degrees, then it is a right angle. I think that one looks good. So let's go back to A. If the number is odd, then it is prime. So if we think about 3 and 5 and 7, those are all odd, and they're prime. 9 is odd, and it is not prime. So that's a counterexample right there. But I also want you to think about 1, because that's the one that throws us off sometimes. 1 is an odd number. Think about whether or not it is prime. 1 is not a prime number. You need to make sure that you understand that. So even though we could get a counterexample out of a number like 9, 1 is also a counterexample here. And so that means that C is my answer. All right, then 15 says, use deductive reasoning to complete the following. The sum of the angles of any quadrilateral is 360 degrees. In quadrilateral PQRS, the measure of angle S is 50 degrees. All right, so the sum of the angles, all 4 angles, is 360. These first 2 just takes 3 angles and adds them up to 360, so either one of those could be true. If PQRS is 50, then the rest of the angles have to add up to 310. So this total right here makes sense. But if I have this quadrilateral, whatever kind of quadrilateral it is, PQRS, and S is 50, it's these 3 angles I'm going to be adding up. I'm not using S again, so this one uses S, P, and Q, but no R, so that doesn't make any sense. My answer is C. All right, 16, I'm going to make a conjecture. Remember, that's just a conclusion. Like, what do you think about this? About the following geometric relationship. The relationship between the areas of a square with sides x and a rectangle with sides x and 2x. So I'm going to draw myself a picture. Here's my square, here's my rectangle, my side lengths are x. Here, this is x and 2x. So all of these statements talk about the area. So the area of the square, x times x is x squared. X times 2x is 2x squared. So the area of the rectangle is the same as the square. Clearly it is not, because it's x squared and 2x. The area of the rectangle is half the area of the square, or the area of the rectangle is twice the area of the square, or no conjecture can be made. Well, I can definitely make a conjecture. But the area of the rectangle is 2 times the area of the square. That's your answer right there. It could have also had a correct answer choice that said the area of the square is half the area of the rectangle, because that's a true statement also. So make sure you read them carefully so that you don't just get the thinking backwards, even when it's a simple question. All right, 17. Use the distance formula to determine if these are congruent. So when I look at these, I can, let's see, we'll start with EF. So I'm going to get my ordered pairs first. So 1, 3 for F, and -3, -3 for E. All right, so I'm going to do distance formula twice, so I'm just going to break my space into 2 here. And my distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. So I plug this in for the length of EF. That is the square root of x2, to make that -3 minus 1 squared plus -3 minus 3 squared. So this gives me the square root of -4 squared plus -6 squared. You give the square root of 16 plus 36. So that is the square root of 52. So now I break that down. I can break that down to 26 and 2. It's a prime number, 13 and 2. So that means that the length of EF is equal to 2 square root of 13. And that by itself doesn't really mean anything because I have to go and find the other one. So the other one is GH. This is at 2, 2. H is at 1, 2, 3. So this is at 3, -4. So the length of GH is equal to, I'm going to make that 3 minus 2 squared plus -4 minus 2 squared. Okay, so this gives me the square root of 1 squared plus negative 6 squared. That's equal to the square root of 1 plus 36. So that's the square root of 37. That's a prime number, so the length of GH equals the square root of 37. All right, 18. One end of a line segment has the coordinates of 7, negative 18. If the midpoint of the line segment is negative 3, negative 4, then what are the coordinates of the other endpoint? Okay, so to make myself a quick little graph here, I said that one endpoint is at 7, negative 18. I'll make it right there. That looks good. And then the midpoint is at negative 3, negative 4. So this is the midpoint. So that means that if this is half the segment and that's the midpoint, my other endpoint is up here. Even if the picture doesn't help you much, it might help you to actually think through it and realize that you are not just plugging these numbers into the midpoint formula. All right, so midpoint formula is very simply just averaging the coordinates. So x1 plus x2 over 2, y1 plus y2 over 2. So in this case, we know the midpoint. The midpoint is, break that up. So you get, my midpoint is negative 3, negative 4. It is equal to the coordinate I don't know plus the x coordinate I do know over 2. And the y coordinate I don't know plus the y coordinate I do know over 2. And then I'm just going to break these into two little equations. I know that negative 3 equals x plus 7 over 2. And I know that negative 4 equals y plus a negative 18 over 2. So that means that negative 6 equals x plus 7, which means x equals negative 13. Here, negative 8 equals y plus a negative 18. That means that y equals 10. So my ordered pair is my final answer is negative 13, 10. All right, so then the figure illustrates the intersection of plane P and plane T. The planes extend infinitely in all directions. What undefined term best describes the intersection? Basically, this is just asking you where do two planes intersect. They intersect at a line. Okay, then the measure of one acute angle in a right triangle is 6 degrees more than three times the measure of the other angle. Find the measure of both acute angles. So you can call these angles whatever you want. I'm going to call them x and y. So one acute angle, x, in a right triangle equals 6 degrees more, that means that's a positive 6, plus 3 times the measure of the other angle. So I can't use x because I used x for one of them. Now it's talking about the other one, 3 times the other one, which I'll call y. So an angle is 6 degrees more than 3 times the other. So my first equation is x equals 6 plus 3y. And I say my first equations because I got two variables, so I'm going to have two equations. These are acute angles in a right triangle, which I know are complementary, so x plus y has to equal 90. So I have a system, two equations, two variables. This is already solved for x, so there's no reason to force it down the elimination route. I totally use substitution here, so I'm going to take that, plug that in for x. So 6 plus 3y plus y equals 90. So that means that 4y is equal to 84. So y is equal to 21. So then I go plug it back in so I can find x. So I'll just plug it into this one. This is going to give me that x equals 6 plus 3 times 21. So x equals 6 plus 63. So x equals 69, which means that both angles, the angles measure 21 degrees and 69 degrees. And there you go. That is part 1.